want to talk about SATs. We are going to do two questions regarding SATs, and so our topic of study is SATs. Okay, in SATs, there's some very important concepts that we must learn before we do these questions. So the first thing we're going to talk about is called trigonometric ratios. Trigonometric ratios of special angles. Why do we need to learn this? We need to learn this because this one is going to help us navigate some questions on SATs, especially when we're dealing with the denominator part of SATs that requires us to use to apply the use of conjugate. So the special angles are 30 degrees, 60 degrees, and 45 degrees. So we'll start with 45 degrees, we go to 30 degrees, then finally 60 degrees, after which we shall talk about quadratic identities. Now, I'm going to divide the board into three parts. So, to get trigonometric ratios for 45 degrees, we draw a right-angled triangle which appears to be an isosceles triangle. This is 45 degrees. So this side is equal to this. We give it a unit of 1. Then the hypotenuse, we know always, if you apply Pythagoras theorem, then hypotenuse squared is equal to base squared plus height squared. Okay, so if the base is 1 squared plus height 1 squared, then we know that that one is going to be 2. Then we find h will be square root of 2. So our hypotenuse is going to be 2. Now we have all the sides of our isosceles triangle. We are now good to go. So we are going to start with sine of 45 degrees, and we know that to get the sine we get opposite over hypotenuse. So the opposite here is 1, the hypotenuse is root 2. So sine of 45 is 1 over root 2. Then cosine of 45 degrees, cosine is adjacent over hypotenuse. Our adjacent is 1, hypotenuse is root 2. Then tan of 45 degrees, tangent is opposite over adjacent. So just 1 over 1, which gives us 1. Now these are the trigonometric ratios for 45 degrees. Okay, the sine, the cos, and the tan. Now allow us to move to another special angle, 30 and 60. Okay, so 30 and 60, we come up with an equilateral triangle with all dimensions equal, and now we give them 2, 2. Then we introduce a height here. Okay, so this one is 1, this one is 1, because this one is equivalent to that part. Okay, and as we know, equilateral triangle, all angles are 60 degrees. So this is 60 degrees, this is 60 degrees. This one has been bisected you have 30 degrees and another 30 degrees. Now before we proceed, because trigonometric ratios only work for a right angle triangle, we have two triangles in this, okay, divided by this line here. So this is a right angle triangle on this other end, then another right angle triangle on the other end. Now it's important to find this length here or this height. We can extract one that we see it clearly. This is 2, this is 30 degrees, this is 90 degrees, this is 1. So this h, how do we get this h? Again, we apply Pythagoras theorem, and we know that to get height is simply hypotenuse squared minus base squared. Okay, hypotenuse here is 2, 2 squared minus 1 squared. Then you work that one out, you're going to get 4 minus 1. And now h alone, you're going to get root of 3. So our h here is root 3. Now having gotten that, we can now proceed to find the trigonometric ratios for 30 and 60. Now we can use this other end. Now let's start with sine. Sine of 30 degrees. Sine of 30 degrees. Sine is opposite over hypotenuse, and opposite is 1, hypotenuse is 2. Then cos of 30 degrees. Cos is adjacent over hypotenuse. So adjacent of 30 there is 3, hypotenuse is 2. Then tangent of 30 degrees. Tangent is opposite over tan is opposite over adjacent. The opposite of this 30 is 1. The adjacent to this angle here is root 3. So this is these are the trigonometric ratios for what? For 30 degrees. Then we go to 60. Sine of 60 degrees. Sine of 60 degrees. Sine is opposite over hypotenuse. And the opposite is root 3, hypotenuse 2. What about cos of 60 degrees? Cos adjacent over hypotenuse 1 over 2. Then finally tan of 60 degrees. Tan is opposite over adjacent. Opposite is root 3, adjacent is 1, which is just equivalent. Now, having found the trigonometric ratios of special angles, these ones will be very helpful as we move on with the study of sides. Now, one thing that I want to highlight is that sine of 30 is same as cos of 60. At the same time, sine of 60 is same as cos of 30. It means these are complementary angles. Now, having done that, we can now move to another level. Okay, the second thing I want us to remind ourselves of is what we call quadratic identities. Quadratic identities. What are quadratic identities? We have 3 of them. The first one, a plus b squared is same as a plus b, a plus b. Okay, which if you square, you're going to get a squared plus 2ab plus b squared. And how do we go about this? We know when we are expanding, we take one item outside the bracket, then you pick the other one, then the second one, then you take that other one, then you expand a by a squared, a by b, b by a is ba or ab, then b by b is b squared. Now these one are like terms, so 1ab plus 1ab gives us 2ab, then this is a squared, that is b squared. So this is the trigonometric, this is the quadratic identity for a plus b squared. Now let's go to the second one, Roman 2. We have a minus b squared, which is equal to a minus b, and this one ultimately will lead us to a squared minus 2ab plus b squared. Now let's see how we get to that. So these are the identities that we want to expand. So you take a, then a minus b, then you take minus b into a minus b, then we expand. Now a times a is a squared, a times minus b, that is minus ab, then b times a could be negative ba or negative ab, then minus b times minus b, you get positive b squared. This one and this one, we have a negative ab and another negative ab, you combine them, you get 2